Okay, so take a look at this picture that I have drawn for you over here. Tell me what you see. Describe it for me. What do you see?
Circle inscribed in a square.
You see a circle inscribed in a square, or a square circumscribed about the circle. Okay, good. So we're gonna pretend that this is a dartboard. Okay, and you're gonna throw a dart at this board here. And assuming you hit the board, meaning somewhere in the square, okay, then we're trying to figure out what is the probability that you would be in a shaded part of the square.
So we're pretending, hold on, dartboard, right?
Dartboard.
Okay.
It's a dartboard, and if you throw a dart at the dartboard, and assuming you hit the dartboard makes up the entire square, what's the probability that it's going to be hit one of that shaded regions? Very good. Yeah, we have to find the area of the circle, and we have to find the area of the square. The question then is like, let's take a guess though. As a percent, it's probability, right? As a percent, should your answer be above 50% or below 50%? You guys think an answer should be below 50%. I wonder then, could you write down your guess? I want you to write down a guess over here, okay? Write down your guess as to what you think the percentage is going to be. And then we're going to actually calculate because I'm going to give you some numbers here, okay? Write down your guess. Your percentage guess. What do you think it's going to be? Alright, so to calculate geometric probability, we're going to use this same formula throughout the entire lesson. We're going to do the target area out divided by the whole area. Yes? We're guessing, yeah, what percentage you think it is. Yep, that's the guess. Okay. So we're going to use, to figure out geometric probability, we're going to do target area over whole area. So we need two things. Nick said, what's one of the things that we're going to need to figure this out?
The area of the square.
We need the area of the square. Okay, so I'm going to tell you right now that each side length is 5 inches. Okay, 5 inches. So the area of the square should be 25 inches squared. You guys cool with that part? Okay, what else do we need? We need the area of the circle, don't we? The area of the circle is pi r squared. So that's pi. What would the radius be if the diameter is 5? So this would be 2.5 squared. 2.5 squared is what? Nope. 2.5 squared is 6.25. So this is 6.25 pi inches squared. Okay, so we have these numbers here. Because that's the radius, right? So from here to here is 2.5 because that's the whole thing is 5. So the radius has to be 2.5. Okay, now what is the target area? The target is the shaded region, right? The target area is the shaded region.
We're trying to get into the shaded
Yeah, the target area is the shaded region, okay? So that shaded region is the area of the square minus the area of the circle. Do you guys agree with that as the target region? Take the square, subtract the circle, that's the shaded part, right? And we're going to divide it by, what's the whole area there?
Plus.
The square, right? Area of the square. So this is our target area, is area of the square minus area of the circle divided by area of the square. Do we know answers for these two things here? Yeah, we just figured them out, right? We just figured them out.
Wait, wouldn't it just be the area of the square minus the area of the circle?
Yeah, but probability is out of the whole thing. Okay? What is the area of the square?
So
25 minus 6.25 pi divided by, what's the area of the whole thing? 25. Okay, we're going to plug that into our calculators right now. So take a calculator out, and I'll show you how to do it. I'm going to move this over so you can see. I want to plug in this expression in my calculator. So here's what I'm going to do. I'm going to put a parenthesis and say 25 minus 6.25, and then I'm going to hit a pi. And the pi is the second caret button right here. So that is my numerator. 25 minus 6.25 pi. That's my numerator. Caret is the exponent. Yeah.
0.2156.
Good. I'm going to get this answer. Push enter.
Oh.
Then I'm going to divide
Oh, divide that.
by 25. And that gives me this. Point. So is my probability 0.21?
It's 21.46%.
Good. You need to multiply by 100 to turn it into a percent. So that's 21.460%. So 21.460%. Okay, very, very simple example here. I have a line, segment. It's broken up into 1, 2, 3, 4, 5, 6 little pieces here. How many points are on that line segment? No, try again. Infinite, there you go. There are an infinite amount of points on that line segment, okay? 7 of them happen to be labeled, right? But there's an infinite amount of points. So here's the question I have for you that we're trying to figure out using that target area over whole area. You pick any point at random, and it doesn't need to be one of the ones labeled. It could be one of the infinite amount of points that's on that line segment. What's the probability that is going to be on CF? Okay. What's the probability that's going to land on CF? Okay, he's asking the question. He doesn't understand. So here's the deal. Okay.
Why is it moving?
Check it out. No. How many points are between CF?
Yeah, 50%.
How many are below there? How many points are in between C and F, including C and F? An infinite amount of points, right? Okay. And there's an infinite amount of points on the whole entire thing. You're going to pick any point at random. What's the probability that it's going to be on the line segment CF, which is this piece that I'm going to highlight right here? Okay?
I thought you were like, choose point.
No, the point's not going to move. The point's going to stay there. So we're going to use the same exact idea. We're going to do target area divided by whole area. Okay, so what is the target area? What's the length of CF?
6.
Yeah, 2, 4, 6. Yep, sure is. What's the length of the whole thing? 2, 4, 6, 8, 10, 12. Oh, look at this. So you have a 1/2 or 50% chance that your point that you pick and create will end up on CF. Okay, this is an interesting problem because it looks like there's not enough information, but actually there is. Okay. Oh, sorry. I didn't put those on there. This is C and this is D. Sorry. Okay. Okay, so you're going to do the same exact thing. What's the probability? You're going to pick a point at random on this line segment from A to F. What's the probability that's going to be between B and C? And it looks like you don't have enough information, but you actually do. Okay, and I'm looking for a percent. Looking for a percent. See if you can come up with it. Okay, so not sure if you realize it. Yes, many of you got it. Many of you got it, but here's the deal. Okay, not sure if you realize it, but the drawing, the way the drawing was set up, AB and BE and EF were all the same. So those 3 highlighted segments are all the same. And then these highlighted segments are all the same. That one, and that one. So with that information, what'd you do?
3 times 3.
What'd you do, Juliana?
I labeled A to B as 3.
A to B, this is 3. Okay, good.
And since B to E is 3 and E to F is 3.
So that's a 3 and that's a 3.
Then I did BC as 1, CD as 1.
That's a 1, that's a 1, and that's a 1.
And then
Very
I
good.
did target area over whole area,
So
so I did 1/9.
your target area, in this case it was 1 because we're going from B to C, so we're talking about this spot right here. 1 divided by the entire area, which is 3 plus 3 plus 3, which is 9, over whole area. So that as a percent is 11.111%. Is that what you guys got?
Yeah.
Nicely done. So for this one, what we're trying to figure out, so what's the probability that if you choose a point inside the circle, that it will be also in the triangle, or in the shaded region? Okay? So what's our plan going to be? We need the area of 2 things. What are the 2 things we need the area of? Yes, sir. Good. We need the area of the triangle. We need the area of the triangle, and we also need the area of the circle. Now listen to the question. I didn't write the question down. The question was this. Assuming you choose a point in the circle, what's the probability that it'll be in the triangle? So our target area is just the triangle, and the whole area is the circle, right? So we don't have to subtract anything here on this particular one. So we need the area of the triangle, we need the area of the circle. I want that side of the room. You guys find the area of the triangle, You guys find the area of the circle. Ready, set, go. So here's the two things that we needed. The area of the triangle was 1/2 the apothem times the perimeter. The apothem was 6. The perimeter was 6 times a 6-root-3.
Wait, how do I know that that's a 30-60-90?
That's a great question, okay? He says, how do you know this triangle is 30-60-90? Well, we know that this is an equilateral triangle, so we know because it's labeled. Okay? They're all... Oh, you didn't see the third tick yet.
Yeah, I didn't see it either.
So that's 60, and that's 60. So therefore, this angle had to be 30 down here because the radius bisects the angle. So now we have the area of the triangle, we have the area of the circle. So what is the target area that we want? Remember, the question is, if we pick a point inside the circle, what's the probability that lands inside the triangle? So the target area is just the area of the triangle, which is 108 rad 3. The whole area is the area of the circle, which is 144 pi. So that is the exact answer. We need to run that through our calculator to get a percentage, and you should come up with 41.350%. I will show you. I'll plug it into my calculator now. That's how I got it. Okay. Here's how you do it. Put parentheses on top. Go 108 second square root of 3. That's my numerator. Divided by another set of parentheses. 144 pi. Push enter times 100. Yep, sure will.